one, we're given actually both equations and graphs. So Mr. Brust is playing catch with his best friend, himself. He throws a tennis ball straight up in the air. The height of the ball is modeled by this. All right. This is a position. Okay. And I just want to point out then that position curve they graph for you below. Okay. So the position function then is equal to negative 4.9 t squared plus 18t plus 2. Yeah. Okay, so I guess I want to start kind of just talking about like making connections. So you're telling me the velocity is the derivative of that, right? So what's going to happen when you take the derivative of something quadratic? It's going to become linear, and I actually then linear with a negative slope if it's opening down? No. If the parabola was opening up, linear with a positive slope? Okay, all right. And then, so if I'm graphing this, well, let's first find this. Okay, so this has got like, if we're thinking of a slope, the y-intercept is 18 and a slope of negative 9.8. Let's sketch a little graph of that, okay? So 18 would be right up here, yes? Yeah. Okay, if we go down 9.8 from that, what would that be? 8.2? Yes? Okay. I think that's enough to, ooh, let's figure out where it hits just for the heck of it. What's 18 divided by 9.8? Because I'm where it hits 0. Can you just do it for me? Okay. All right, so just in general, like knowing quadratics have something linear. What would the acceleration be? Equation-wise. And then when I have something linear, the slope is going to be constant, and so that would look like a horizontal line at negative 9.8. Does that kind of make sense? Okay. Which just means the acceleration for the function's constant, and it's the same acceleration the entire time. All right, let's talk about what these things mean. Let's see if you've picked up on that. If v of t is less than 0, what does that mean about the particle? Okay, yes, normally yes. And this one, the ball is going up and down.
Oh, it's going down.
And if v of t is greater than 0, the particle, that means what? So when v of t equals 0, what does that mean? Well, a couple things. The ball is, but remember this is instantaneous, so you're right, is momentarily stopped. Yes. But if that's the point when the velocity stops, but here it was positive and here the velocity was negative, what actually happened there? So the tennis ball is going up. It stops momentarily because what's going to happen? What happens now? now it's going down. And so obviously it's got to hit 0. It's just for an instant. It's not like you're looking at the ball and it's, but do you know what I'm saying? It's like, oh, stop. It is. You probably won't ever be able to see it because it goes up, it stops a second and comes down. Not even a second. Okay, so the ball stops and this is when it switches directions. Okay. I told you before that average velocity is not a calculus thing. So average velocity is the change in position over the change in time. So this would typically be asked over, not typically, it would be asked for an interval. So I might say, what's the average velocity from 1 to 2 seconds? So then you'd have 2 points in which to find the slope. Okay. What did we say about speed? We graphed it in the question that Paul just asked. Yes, the speed is the absolute value of the velocity. Okay. The velocity speed is not the same thing as the question, is the particle speeding up or slowing down? Okay. So that's, I want to talk about that and we'll write it down because we didn't write that down before. If velocity and acceleration have the same sign, the particle is speeding up. If velocity and acceleration have different signs, the particle is slowing down. Okay. At your tables, I have a time, so specific time, and I have the velocity and the acceleration at those specific times. At your table, can you come to a conclusion about what the particle is doing at -5, 1, 2, and 4? Just real quickly, based on what we just talked about. Okay, conclusion. What did you say here? Slowing down. How about here? Slowing down. How about here? Speeding up. Last one? Okay. So the negative and positive just is telling you about the direction of the body and the direction of the acceleration. It's not telling you if it slows down or speeds up. So you do have to look at both signs to do that. Good? Cool. All right. Let's see what we got here. Oh, what is displacement? The displacement's just the change in position. And so in this, like, this tennis ball was moving up and down. Well, actually the tennis ball moving up and down, once we got back down to 0, we wouldn't even measure it. Whereas a particle on a number line, even though that maybe doesn't make a whole lot of sense, because it's not like you see particles on number lines, but we're going to do it a lot this year. But you can have it be negative because you can go to the left on a number line. But yeah, displacement's just the change in the position. So you would subtract like if I said, what's the displacement in the first 5 seconds? You'd take s of 5 minus s of 0. And that's basically where is, or how much did their position change in that time frame. Okay? All right. I feel like we did this. Oh, I don't know. I want to do one of these. Would you guys rather do an equation or a graph? Do you feel like you need more practice with before I let you guys work on some things? Okay. All right, so let's do this example, particle motion from a graph. First of all, would you just double check and would you circle or highlight what graph you're looking at so you know which one it is? There's a label. No, look at the label. Okay, what am I looking at? Velocity. So in my head, above the x-axis means it's positive, below the x-axis means it's negative. Got it? Okay, 6. What is the particle moving to the right? Nope. Don't, just, you gotta really think. Don't flirt. Think in your head, when is it moving to the right? It's when the velocity is positive and I'm looking at the velocity. What do you think? Okay, positive on looks is above the x-axis. 0 to 1, she said. Where else? Might have to approximate. 4.5 to 7. Justify. This is very important. This is very AP-like. All you have to write is V of t is greater than 0. Okay, when is the particle moving to the left? Then. One to 4.5? Yay, why? Because V of t is less than 0. It's below the x-axis. Okay, now I ask about the acceleration. The acceleration is the derivative of this, right? So now look at the slope of the, think about the slope of this. When is the acceleration? Positive. Who feels pretty confident? Deanna. Okay, so from 2 to 6, this, yeah, so I'm going to write 2 to 6, and this is what I'm going to write. I don't have the acceleration. I'm going to write, that's where the derivative of the velocity, or the slope of the, you could even use the word slope of the velocity, if you want, is greater than 0. By the way, it could be this. It could be brackets. Negative. Yeah, you're right. It should be a parentheses. No, because on these ones, this one is asking about the graph that you're given, but since this is asking about the derivative of what you're given, these, it's not differentiable at the corners. Okay. She's right. I'm wrong. Negative. Zero to 2 and 6 to 7. 0 to 2, 6 to 7, and we would say, because V prime of t, you could say A of t if you want, if you'd rather state it that way. They would accept either is less than 0 or the slope of the velocity. And when is the acceleration 0? You agree with that? You could, I don't like that question. No, they won't, I don't think they'll ask with this, if when the acceleration is 0, they wouldn't meet with the curve. Because here's why it's not defined at those points. You can't find the derivative at that point. If it were a smoothed out, you could, yeah. So it's 0 never. Nine, when does the particle have the greatest speed. Remember, the greatest speed is the absolute value of the velocity. So you're looking for the one furthest from the x-axis. So at 0 and at 2. Oh, this is a good question. Oh, this is hard to see. Okay, in my head, guys, I have to even keep this straight. The particle is going to be speeding up when the velocity is above the x-axis and it's sloping positive, because that's when the sign would be the same, or below the next x-axis and sloping negative. I'm going to try to highlight some spots. Okay, it's not sloping positive, is it? This right here, it's positive, but is it sloping up? No, so the acceleration and velocity do not have the same sign here. Down here, the velocity is negative and the acceleration is negative, right? So that's going to be a spot where the particle is speeding up. Okay, let's find another one. Here, the velocity is negative, but the acceleration is positive, so not. How about right here? Yeah. So the particle is speeding up from 1 to 2 and 4.5 to 6. And I'm going to write it's as simple as this, guys. Since A of t and V of t have the same sign. That's all you have to do to verify for AP. And honestly, they'll still give you points for the statement if you get the answer wrong. They'll give you some points for getting that justification correct. All right, so when is the particle slowing down? We would say then 0 to 1 and 2 to 4.5. And the reasoning is since A of t and V of t have different signs. Thank you. Jolly. I have several jollies that I have to give out today. One to Natalie. I think the reds are the best, so I don't know why all those ones are still in there. Some weird people taking all those different ones. What? Blue is the best? Were there any blue in there to begin with? I don't know if that sometimes. Could be. He hasn't been in here for a while though.